Okay, now let's have a look some question related to mensuration of a solid. Okay, this few questions is a style question of DSE. Okay, let's see. The first one, okay, is similar to the sample paper question 6. Let's have a look all together. Here, the figure shows a solid consisting of a hemisphere and a right circular cone. That means like this, okay, like an ice cream, right? The radius of a hemisphere is RCM. So I write here RCM. And remember, for a hemisphere, here is R, here's R. Whatever start from the center of the hemisphere or sphere, then to the circumference, okay, of the hemisphere, or on the radius, or the distance of the radius, okay? And height and the base of the cone are 20 cm and RCM. Here is height, so height is 20, okay, base is R, okay, so here it's given that the volume of a cone is 2 times that of the hemisphere, okay? This one cone, cone is this one, okay? Here is a cone, okay, and this one is the hemisphere, okay, and the volume of the ratio, okay, or the relations between these two is 2 times. Cone is 2 times of a hemisphere, okay, 2 times of it. So the first thing, A, find the value of R, and B, express the volume of the solid in terms of pi. After you know R, then I think easy for us to find out the volume of the solid. How to find the value of R? This is a relation. That means we need to know volume of a cone. What is the formula? Do you remember? And volume of hemisphere. Do you remember? Yeah. About the volume of hemisphere. Yeah, very good. Very good. Half of the volume of a sphere. So half of 4 over 3 pi r cube. So it's 2 over 3 pi r cube. Very good. How about volume of cone? Good. So this one, 1/3 of pi r square h. Okay, pi r square h. So you know that cone and hemisphere volumes. Now, because volume of cone is 2 times of hemisphere, so just make use of this two formula and substitute the values that you know. We just know about the height of the cone, so here we can substitute the height of a cone is 20. So after that, easy, right? So 1/3 pi r square h is 20, okay? And equals to 2 times 1 over 2 times 4 over 3 pi r cube, okay? After simplify pi r square, you left r here, and 4 over 3. Here is 20 over 3, so at the end r is 5. Remember? Cm this time is omitted because we have cm here, RCM, okay? So no need to write cm here. Please pay attention. Part B, express the volume of the solid in terms of pi. So just make use of the formula here and substitute values of R and value of H. So easy, use the formula only. That means here 1 over 3, okay, pi r square h, right? Plus 2 over 3 pi r cube. So at the end, 250 pi cm cube. Remember here cm cube. Don't miss the units. Okay? That's great. Question 2, you can do it by yourself. Okay? Let's have a look here now. Then you can do it by yourself and check it later. Now let's have a look. Number 3. Okay, this question again related to DSE 2012, question number 9. Let's have a look. Now here in the figure, the volume of a solid right prism. Okay, here, solid right prism. This one is a prism. Okay, so you need to think, okay, later on. This volume is 1080 cm cube. Given that angle PQR 90 degrees. Okay, I mark it here. QR 12 cm, QU 20 cm. Okay, find the length of PQ. I mark question mark here. Length of PQ. B. Total surface area of a prism. Okay, this all okay. So total surface area. Think about how many faces you need to count. You need to calculate. Okay, later on, let's see. About the volume of a solid right prism. I want you to make sure which part is the base area and which part is the height of a prism. Here, base area, that means you have the same uniform cross-section area. Okay, so these two are the base. Okay, these two are the bases. Triangle PQR or use triangle TUS. They are the same. Okay, so in between two bases, this is the height of the prism. That means QU, PT, or RS, both of them are the height of the prism. Okay, so later on we can use this relations to find the length of PQ. So now, if we know this one as a base, 20 as a height, that means base area times height. So do you know the area of a base? We don't know, but we just know the volume of this prism. So use the formula, right? Volume is equals to base area times height, right? So now the base area is a area of a triangle. So very easy, 1,800, right? No, 1,080, sorry. 1,080 equals area of a triangle, PQR times 20, okay? So this area is PQ times 12 over 2 because these two are the base and the height of a triangle, okay? This is the height of prism, okay? So times 20, keep it. Area of triangle, PQ times 12 over 2. So lastly, we can find PQ equals 9 cm. Remember the length of PQ, you need to write down the unit cm here. Okay, don't miss it. Okay, not difficult, right? How about part B, total surface area? Two bases, and here are the three sides of the base area. So at plus 3 faces, there are total 5 faces. You need to calculate. And 3 lateral surface area, do you know how to find it? You know 12. You know PQ is 9. How about PR? Yeah, we need to find it. Otherwise, we cannot find the area. So, about the total surface area, actually, total lateral surface area plus 2 bases. And do you know the perimeter? We don't know PR. Okay, we just know 12 and 9. So 12 plus 9 and then plus PR times the height of a prism, 20. And then add up 2 areas of triangle. 2 areas of triangle. Okay, 9 times 12 over 2. So we need to find PR. Do you know how to find PR? Yeah, here we have a right angular triangle, right? So that's 2 lengths. Yeah, using Pythagoras theorem, correct, okay? So we use this triangle. PQ 9 cm, QR 12 cm, and we can find PR, right? So PR, not difficult for you to find it. Let's see. PR square, okay, just maybe okay. PR square equals 9 square plus 12 square, so PR is 15. So at the end, not difficult. That means here, 20 times this one, the perimeter of the base area. 12 plus 9 plus 15. Okay, so at the end, 828 cm square. Again, don't miss the unit, cm square. This one is the area, so square. Okay, any question? No question, right? It's easy. So just have a look. Question 4, you can try by yourself and hope you can know, you can find the answer of A and B. Okay, check it later. Let's have a look one more. Question 5. question 5. Okay. The ratio of volumes of two similar cylinders is 27 to 64. This one is the ratio about the volume of similar cylinder. Okay. Part A. Find the ratio of base radius of a larger two smaller cylinder. Okay. Find the ratio of the base radius. Okay. If you know about the volume ratio, you also can find back the ratio of the lengths. Radius is one of the length of these two similar cylinder. Large to small. Okay, later we check it. Have a look part B also. If total surface area of smaller cylinder is 81 cm square, find the total surface area of the larger one. Okay, you have the smaller one later on to find the larger one. Okay, we understand about the question now. So maybe you can roughly to draw these two figures like this. See? Small cylinder, large cylinder. They are similar. Okay, so R to R equals to H to H. Small r to big R equals to small h to a great H. Okay, so yeah, volume and the base radius. If take cube of the ratio of the base radius, well, equals to the volume radius, volume ratio. Okay, so do you remember this relations? Yeah, V1 over V2 equals L1 over L2 and then take cube, right? So here, maybe you think that, oh, is it this one? If you want to find the length, that means cube root of this ratio, 64 over 27. Okay. L1, L2, okay, depends on which one is 1, which one is 2, whatever. So remember, here is the base radius of a larger cylinder. So 64 as numerator. Then smaller one, that means 27 as denominator. Okay, I will write like this. So here, 64 to 27. So as a result, that means this one is big R to small r, right? And then cube. Okay? Okay? That means this one, right? So at the end, okay, maybe I choose this one at the side. So at the end, you can find the ratio of R, big R to small r is 4 to 3. Okay, 4 to 3. So remember, write down your answer. The required ratio is 4 to 3. 4 to 3. Okay? Then how about the total surface area? Because now we know one of the total surface area, then you can find the other one. Because we can make use of the base radius ratio to find the area ratios. Okay? So area A1, A2, well, with the L1, L2, and then take square. Do you remember? Good. That means now if we know that this one is 4 over 3, 4 to 3, large is 4, small is 3, then take square. What will be the ratio of the total surface area? Right. So at the end, substitute all the information that's given. Okay. You know the one smaller is 81. So this one times 81. So 16 over 9 times 81 will be the total surface area of the larger cylinder. So as a result, 144 cm square is the answer. Understand? Okay. So this question makes use of the ratio, then to find ratio of the volume to find the ratio of the radius. In the same time, we can find the area, total surface area. Okay. So maybe question 6, you can have a look and do it by yourself and check it later. Okay. Question 7 will be the last question in this video. Let's see. 7. The sum of the volumes of two hemispheres is 4,032 pi cm cube. Radius of a large hemisphere is 3 times that of the smaller one, okay, given the relation between the large and the smaller one, okay. Expressed in terms of pi, A, volume of the smaller hemisphere, B, the sum of the surface area of 2 hemispheres. So again, I will roughly to draw this 2 hemisphere like this, okay. Not so beautiful, right? But you understand. So you can also draw and then help yourself. Here is the R, and you know that the big R, larger one, 3 times that of the smaller one. Okay, so in this question about the volume and also about the surface area, do you remember the volume and the surface area formula? Okay, give you 3 seconds. Time's up. Okay, so let's see. Here is the volume and the surface area. About the volume of a hemisphere, 1/2, that means half of the volume of sphere, 4/3 pi r cube. So this one, 2/3 pi r cube. About the surface area, again, remember you have the curved surface area and the base circle. So half of surface area of a sphere, 4 pi r square, okay? And then plus base area. That means a circle. So total 3 pi r square. Okay, now part A. What is the volume of a smaller hemisphere? You know sum of these two over this. And you know that R, big R is 3 times of a small r. So I think not difficult for you to write down this relationship. Okay, small volume plus the large volume equals to 4,332 pi. Then this r, actually you can write as 3 small r cube, right? So let's see. We need to find it, okay? Then you can know about the radius. So you see, only have one unknown radius. After we know the radius, we can find the volume, right? So let's see. Here is 3r cubed. Remember, all cube, that means it's 27r cubed. Don't miss it, okay? And 2/3 pi, 2/3 pi can simplify, okay? And lastly, r cubed equals to our value, then you can find r. After you know our small hemisphere volume, you can find it. So 2/3 pi r cubed, so 144 pi cm cubed. Again, remember you have the units of volume. That's great. Part B, maybe we can easily find it. Sum of surface area of 2 hemispheres. That means you add up these 2 surface area. 3 pi r square plus 3 pi r square. One is big R, right? So let's see. Have a look. Now, 3 pi small r square, okay, and then plus 3 pi big R is 3 times of a small r. So 6 times 3 and then square. So at the end, 1,080 pi cm square. Again, this is a surface area, so you write down the units of the surface area, cm square. Okay? Oh, so hope you understand about simple relation and the simple question about the volume and the surface area of the solid.